the output is wrong. The system cannot modify it automatically. It's wrong, we show by this worker to modify the system. Now, compute control input without continuous variable measurement. But this system is simple. It's very simple. Now it's very widely used. And need to know actually to work right. We have some machine related to open loop computer system. Now is cruise control car. Current car is breaking run angle, and this e-commerce server white load. What is open loop computer system false when we don't know everything? We make errors in estimation or modeling, or things change. This open loop computer system will burn. Now, this one machine is a computer system. It is a mathematical machine. Also is open loop computer system. Open loop. If we want what matter? We import. RMB. 5元 import. We show the play this key, and then this watermelon is run out. This is wet machine. This open loop computer system. Now this is also open loop computer system. Automatic panel machine. He's worker 24 hours, but if he runs out, sometimes if your price only take from 100 yuan, maybe he put out 300 yuan or some others, but he cannot modify this error. Should modify it or change this result by these workers. So this system is open loop computer system, and this also automatic flow production line. This line in many manufacturers. Now this production of this factory is work step by step. We cannot come back. We come back. You workers step by step. No, we only forward, not come back. So this is also an open loop computer system. Now, the other is this closed loop computer system. Now this closed loop system is the important system we will study in these classes. This is a system in which the output has the infer input quantity in such a manner as to make the desired output value. That is a system that uses a memory of the output and compresses with the desired output. This desired output also this input. This means, for a computer system, if the system is not what the output is not what we want, the system will modify it itself and then make it work to what we want, to the state what we want. Now, here we should need the feedback element. The unit provides the minimum value for feeding back this output quantity. For a function of output, you want to compare it with the reference. Now, this feedback values, it is the unit provide this measurement value. We also create the observer. It is used to observe this output of these systems, and also feedback this value to this input and compare it. Then there is an error. The error will automatically this control. Let's see this car. Now this car is running on the road. Now two should control. One is this direction, and the second is speed. Two. Now in physics, it is one. It is the velocity. Velocity control the two part. It's the speed. Another is the direction. But for this car, these two elements is controlled by two elements. Now we can see when the car is running on the road, there is a desired direction of the trail, and another is the actual direction of the trail. Now, if the actual direction of the trail is not the desired direction of the trail, now let's see there is the error. There is the error. The error is the error. The error is this desired direction and this actual direction, the difference of the two directions. Now, if we find that, there is a direction, we should calculate still. Now, start to make the direction is 0. Now, we see there is the closed loop control system. Now, the figure of the control. Now, here we have the desired course of travel. Now, in fact, the output there is the actual course of travel. Now, the two, we can use the measurement to view or to see the actual close of the trail. Now, this is feedback to this input. Now, the two is the error. There is the error. Now, the error, if the driver sees the error, then he will steer the machine. And the machine will control this car, and automobile will modify its direction. And this direction, and then we can get a new actual course of the travel, or a new direction. Now we will see what's the direction of and this actual direction and this desired direction. If they have the error, then steering this machine. If no, we will stop. So this is the first loop control system, also closed loop control system. Now we use this desired direction of travel and this actual direction of travel. We can see this black line is the desired, and this blue line is actual direction. The two, there is the error. The error we can see with the time change this arrow disappeared. This arrow disappeared. We can see the measurement variable are used to compute control input. And the more complete, so we need the control cell continuous measurement and query. And the embedded network change the back of window. We show that need continuous measurement and query. And then another, the feedback control cell makes it possible to control even if we don't know everything. Maybe we make some errors in estimates or model or set changes. Now, this is for me. Maybe have this cases or situations. Now, we can use the feedback control system or the closed loop control system to modify the error. Now, the control systems are used to achieve first increased product rate. Now, it is very observed. If we do some by main hand, it's very slowly. But if we do it by machine, it's very quickly. If we work to one, maybe many days. But if by car or by train, it's very quickly. So it's also the same meaning. Will improve the performance of a device or systems. The control of an inductive process will by automatic rather than by manual means is often called automaticity. So automaticity is used to improve productivity and open high quantities product. So what this perfect of this automation, what it is? First, improve productivity. Now, 7, obtain high quantities. Now, we shall introduce the history of automatic control. This history of now, the first automatic feedback control used in an industrial process is generally agreed to be James Walt's flyball formulates. It is very famous. It is developed in 1769 for controlling the speed of a steam engine. This is James Walt's flyball formulates. It is used to control these systems. Now, the one mechanical device showed in this figure measured the speed of the output shaft and utilized the moment of the flyball with speed to compute the variable and therefore the amount of steam enter the engine. As the speed increase, the ball reaches rise and move away from the shaft axis. Close the variable. Next is Maxwell's formulate the mathematical theory related to control theory. Use a differential increasing model of a governor. This Maxwell is a very famous scientist. Now, the third is conventional control theory. It is effectively applied to many complex design systems. Now, especially thinking input, thinking out systems. It is the mathematical foundation of the Laplace transform.
transform.
Laplace transform. It's very famous.
It's very famous.
Very famous. Why we should use this Laplace transform? Not by this some formulas we have studied in mathematical classes. We have studied many methods for no differential equation.
The famous man.
Why we not use this method? We should use the Laplace transform. What's the use of it? Because what we study this in our mathematical class cannot show these different equations in our concrete systems. We can't know this equation. So we use the Laplace transform to transform the differential equation to algebra equation. And the algebra equation, we can go to this root, and then by this inverse Laplace transform, and we can get this solution of this equation, differential equation. This is what this Laplace transform's use of this class. Yes. Now we can say this is the input, and this for the process, and this is the output. This process should be controlled. Why we should control it? Because we want to get this design response. And then there is an effect. The effect is the actual response. Now, for the open computer system, it can realize an actual device to compute this process directly without user feedback. Another open loop computer system is like this. This is also an open loop system. We can see here is the open loop system. This is very simple. And more generally, for this open loop computer system is like this. Let's to see for this process there is an actual devices, and then also have a distributed input. This input will distribute this input or the process, and also this output is not very what we want. So the distributed input is not what we want, and in many amazing devices we should tie our breath to make this disappears. Now, the control actual action is calculated at the initial time t0, and then applied to the physical system over the entire computer control horizon without modification. The output is not updated for this computer system. The system used a controller or control actuator to obtain the desired response as shown in this figure 1.3. Now, this system will add this desired output response as this input. Now, here we also give this actual devices. Now, this is put on this process. Now, we change the output. This figure we also call it open loop computer system because it has no feedback. It has no feedback. So, this system is also this open loop system. It's the third type. this is 10. Now, the main of the output is called the feedback signal. I sample closed loop feedback control system. Now, is as the next figures. We will see the advantage and the disadvantage of the two type of control system. Now, we can see this feedback system or closed loop control system. Now, we can see the constituent of feedback control system include two parts. Now, first is the plant and other is controller. The plant, what is the plant? The plant is this device, plant or system, and control is the plant. Now, the main mental parameter is the sender or component. The other controller amplifier is this actual devices, component. This used to control this system, controller. Let's see. This is the structure of a general computer system. Also, a closed loop computer system. We can see this is the input. Now, here is a compare devices. The compare devices is compare the input and the output. Then we have a compensator to or an amplifier. The amplifier is to amplify this error of the system, and the error is expelled. It is to add to the actor, and then we give that to the output. This is the feedback control system. The next is the analysis of the system. The analysis of the control system, the stability is the most important thing for the control system. Because this system is not stable, it can not work. It is rust up. It is no use for us. So the system must be stable. So this stability of the system should be analyzed. We should be analyze the stability. Now, the second is the performance. It is the transient and steady state response of performance of the system. This also there is analysis of control system. We can say the system. It is the stability of the system. We can say the red line of the system is not stable, but the attitude 3 is stable. With the time change, the result of the system is stable. Now we can see the 4 also stable. Now we can see the right line is lost. Okay. The control is terminology. Control is the design and analysis of systems, actors, and computation system analogy or easily called to modify the object, to modify the behavior of physical systems. Now, what's the control? Control should be changed, should be modified, should be give some difference. The behavior to make this output of the system to what we want, what we expect. So the control is the spirit is this soul of this class. Now, okay, this class is here. Maybe we want you, want you to review our this PT and some terminology should be understand it, and we can use do some experiment. And in the next we should do some device that your monitor do some experiment or do some
Can I take
this car to make the car to run you according you want.
So can I bring from my room to here?
Yes, welcome.
I will. Next plus one.
This one, this is this class with what we want. Now, next class we want you to come to the to class in time.
Today is finished?
Yes, this is